Today we're going to be taking a look at the Pasco Capstone Software as well as the smart carts that we will be using to collect real-time data. We're going to be looking at how to get the equipment out, how to set it up, connect it, as well as how to collect and analyze data that we have collected in real time. We're going to start off by getting the equipment out, and I'm going to walk you through the steps to connect the equipment to your computers. Now that we've got the equipment out, let's take a look at the carts that we will be using. Each cart box will have a number on it that corresponds with the number on the cart that is inside of the box. So that is important to keep track of. When you open it up, you'll see a charging cord as well as the cart. We'll get everything out to begin with so we can take a look at everything that is in here. Once you get the cart out, you're going to want to set them upside down like this. And also in the box are different adapters for this end of the cart. The one that is on there by default is the magnet, but we can change that out to a rubber bumper or a metal hook. We do that simply by unscrewing the piece that is attached to the end and screwing the other piece in. The majority of labs we will want the magnetic bumper on the end because that'll actually help slow the cart down as it's on the track so it doesn't smash into the end. But to change pieces, you screw it in, turn it finger tight. You don't want to tighten it too much. Then we're going to put the plunger in by holding the button down on top and pushing that in. Now I'm going to go ahead and put the magnetic end back on, and then we will look at how to power it on and connect it to the computer. When you are putting the magnetic bumper back on, it has a metal piece here as well as a small hole in the cart. We want to line that up so that we know that the magnets are set with the proper polarity. Okay, magnet is back on. It is finger tight. On this side of the cart, we see the power button right here. We're going to hold the power button. We'll see the lights come on and start to flash. The Bluetooth light should start to flash red. That tells me it is in pairing mode. So I'm going to set this down and go back to my computer. From here, I'm going to select Pasco Capstone and get that program loading up. It is a fairly robust program, so it may take a little bit of time for your computer to load all of it. It may ask you to update. We don't have administrator access to put the updates on the computers ourselves, so you're just going to click skip. Once we are loaded up into Pasco, we need to next connect our cart. Here's where that number that is on our cart comes in handy. Each cart or each piece of equipment will have a unique number. You need to know which one you are connecting to. I have cart 571-203. I'm going to come over to Hardware Setup along the left side of the software. Click that. Make sure the Bluetooth option is selected, and it will bring up a list of all of the carts or equipment that I can connect to. Right now the only one that's powered on is the cart that I have. I've checked the number, it lines up. I click on it and it will start connecting. So it will take it a little bit of time, and you'll see once the cart is connected, the light will begin to flash green instead of red. You can check to the battery level of the cart as well as make sure all of the different sensors are turned on. So you see the blue switch is to the right. So I can close out hardware setup. Now we need to look at the different sensors that are in the cart and how to activate them. Once we've connected to our cart, we've leveled our track. We'll set the cart on the track. Try and keep the plunger from going. Now let's take a look at the software and what we need to do in the software before we're ready to collect our data. The first thing we're going to need to do is look at the sensor that is connected. Right now the Smartcart gyro sensor is the one that's connected. That is the gyroscopic sensor. We also have a position sensor, which is an encoder in the wheels. We have a force sensor, which is up here on the front. And we also have an acceleration sensor built in. We're going to select the position sensor for this one. Most of the time here at the beginning of the year, that's the one we're going to want to look at. We also, right beside that, have our sampling rate. So 20 hertz will take 20 samples, measurements per second. We can increase that, we can decrease it. Especially here at the beginning, 20 is a pretty good sampling rate. 20 data points per second will give us plenty of information on what we are looking at. The other thing we can look at, we have continuous mode, keep mode, and fast monitor mode. We're going to stick to either continuous mode or to keep mode. Continuous will collect data constantly until we tell it to stop. Keep mode will only collect the data when we tell it to, so it'll only collect 1 point at a time. We're going to stick with continuous mode for this one. And then here you see the record button. That's what we will use when we are starting to collect data. To set up our chart so we can see and visualize our data, I like to use classic templates, and the one I like the most is the chart and graph in the upper left. This one gives us the best information as well as a good visualization for it. For this, we're going to set up a position versus time graph. So I'm going to change the parameter on the y-axis to position, and in this case it automatically changes the x-axis to time. I also want to select position and time over here in the chart. That way I see it both in chart form and in graph form. Once we are set up and ready to go, we can start collecting data. When we click the record button, it takes a small delay before it starts recording. So when we are collecting data, we want to make sure that we are hitting record before we start, letting it run for a second or two, getting that beginning, because we can always select that out once we have our full data set, and then we click stop. Let's take a look at collecting a few runs of position versus time. We've set up, we're ready to collect some data now. I'm going to start by setting this up, pushing the plunger in 1 notch and bringing that back against the end. So I remember I need to start recording before I'm ready to trigger my position. So I record, give it a second, it's just started recording, it's going. I'm going to push the button to trigger it. And I can see on my graph the position is going up and it's stopped with the cart stopping. So I can stop my data there. There's my first run for this. I'm going to bring it back. I want to push it in 2 notches and do the same thing. Rest it up against, hit record. It just started. I can hit the button. So I can measure the position. In this case, it actually bounced back. Getting an interesting looking graph. I'm going to let it finish out here. So it's come pretty much to a stop. I'm going to go ahead and stop data collection. And then lastly, I'm going to push it in all the way. And I'm going to get a couple books to incline the ramp with. These are the official track incline books. They can be found in the back room. I'm going to raise the track up, set the feet on top of the books, I'm going to measure the same thing. I'm not going to use the plunger this time. I'm just going to let it go. So I'm going to rest it in here, hold it back with my finger, hit record. It started, and I just let it go. So it knocked it off track, but it stopped with position. I can stop it. So now let's take a look at how to analyze this data and gather information from it in Pasco. Once we've got our data collected, we need to start analyzing it. So let's look at the software and the tools that it has to help us analyze our data. When I hover over the graph, it gives me a lot of options along the top. Looking at these, there's a couple that are going to be more useful. The multicolored triangle with the drop-down menu will allow us to select multiple different runs. So I can look at different runs here. I can also select which one I want to look at, or I can look at all of them and see them all at once. I want to turn them all off except for run 2. So this is the one where I had just depressed the thing 1 notch, and I can select it and I can see the graph here. The next tool we're going to use is right beside that. It is the highlight function. So we can highlight a range of data. When I click on it, it gives us a box that I can resize, and any data point that is inside this resized box will be selected. I'm going to select just the beginning of this graph, right through here, right after I triggered the spring, because that part right there looks a lot like a line to me. So looking at that, I can do a regression. I can get a line of best fit. The way I do that is I come back up here. I see a line going through some dots. We'll click the drop down menu beside that, and it gives me a bunch of different regressions. It gives me linear, weighted linear, quadratic, cubic, so I can fit any kind of curve to this line or to this data that I look at. Looking at this though, it looks pretty close to linear, so I'm going to select linear, mt plus b. We can think of it as y equals mx plus b, but in this case it gives us t because we have time. I'm going to select linear, close the menu, and it will give me the parameters. M is the slope. So the slope of this segment of line is 0.360 plus or minus 0.0024. So this plus or minus and the number after it is simply the uncertainty or how much error there is in this measurement. Every measurement we take has some inherent error in it. The smaller that error value, the better our number is. B gives us our y-intercept, which in this case isn't terribly useful for us because I'm just interested in a slope of a position time graph. I can delete other data out, rescale it so this is at 0, but for now that y-intercept isn't terribly useful. And the third parameter it gives us is R. R is how good that fit is. The closer to 1 or -1 R is, the better the data fits. So in this case we're looking at a linear regression. R being exactly 1 tells us that this is a near perfect line. So this data that I have selected is a near perfect line. And you'll see if I resize this and start to include data where it starts to look like it curves, that R value decreases. So now we're down to 0.988. So this is less linear. So I'm going to go down till this is back at a 1 and select as much data as I can that fits a perfect line. So you can see just that beginning is a perfect line. If we get too far, it starts to curve a little bit. Let's look at the other runs and do the same thing. So let's look at run 3. We'll pull run 2 down, and I did the same thing, but this time I depressed it 2 notches. So I want to select linear. But you'll notice, since I didn't select any data, it's doing a linear regression for all of the points. So this line right here isn't telling us much useful. So I need to make sure I come back, select my highlight, resize the box, and drag it to that beginning part right where I let it go. I want to make sure that I don't get anything at the bottom, because I see my R jumps up. So right here we're at a pretty good R value of 1. So this one is really good data. And we have a lot more points in this one where it is linear. Again, we can see our new slope and our new intercept. Then let's do this one more time with run 4. So looking at this, nothing in here really seems linear. It actually looks like it curves. So in math class, if we have a curve, we typically describe it as a quadratic. So I want to try a quadratic fit for this one. So I want to select quadratic. And again, I noticed that it doesn't fit well, but I've also forgotten to highlight and select some data. So I'm going to take the highlighter, select some points right here, kind of try and grab where it's curving, but not that flat part before it started. So now for this one, we have RMSE, root mean square error. The smaller that value is, the better. So the closer to 0, the better for a quadratic fit. But you can see it will give us the A value, as well as our error, our B value in the error, and our C value and the error associated with it. So sometimes it makes more sense to do linear, sometimes it makes more sense to do quadratic. There may be times where we use other kinds of fits, so make sure you check what we need to be using or what our equations look like while we're doing it. The other place that we may want to look at data is in our chart. Moving over to the chart, you'll see it's still got run 4 selected, and it'll even highlight the data points that I have selected in it. I want to change to run 2, go back to that, and I want to rename this. So I'm going to click on it and say rename. So rather than just saying run 2, I want it to be 1 spring notch. That's more descriptive than run 2. Then I hit enter, and that run is renamed. So if I look at it in the list, it will rename it there, and I can select it. I'm going to go through and rename all of the runs to something more descriptive. Now I've got my data renamed. Each of these is a little easier to pick out what information is in it now. Not only, it's no longer just run 1, run 2, I can see exactly what I did for each run. Let's take a look at how to set up a velocity graph. Now we're going to take a look at getting a velocity versus time graph. I'm going to come over here, change my data to velocity, and we'll typically see a little bit of holdover from previous runs, but I'm going to keep that the same, leave that there, and I'm going to delete out test data. So that first run I did that wasn't really useful, I'm going to delete that out so it's out of the way. But I've got it changed to velocity. I've got my track inclined, and I'm going to measure so that I can calculate an angle that the track is inclined. So this is 8.60 centimeters, and this one is 17.98 centimeters. And I also see the track has a length of 228 centimeters. So I can use that to calculate the angle that the track is inclined. I'm going to keep the books the same. I'm going to set my cart on the track, hold it back. I'm set up for data collection. I've changed to velocity. I want to change the chart to velocity, and then I'm going to click record. So it starts recording. I let it go. So it knocked it off, but I can stop there. So there's my first data point. I want to add another book and do the same thing. All right, I've got my data collected. I'm going to rename my runs, and then I'm going to save it. Now I can save my data so that I can either submit it or save it to work on later. I'm going to save experiment as. I'm going to give it a little bit of time to load. And then I find where I want to save it. For now, I'm just going to save it on the desktop. And I'm going to save it as inclined track runs. Saving as a Pasco Capstone file. Save. So now I have access to this data anytime that I need it. Once I've finished collecting my data and I'm ready to put everything away, to power the cart down, I hold the power button until I see the battery light turn red, and then I can let go. That powers the cart down. I can close Pasco out. I can either save my work or I can discard it. And then to put everything back in the box, I start with the extra ends for the force sensor. Put that in the bottom. Then I put my cart in. I'm going to push the magnet end of it to one end. Going to neatly and gently roll the cable up, and it will go against the end of the cart with the plunger. So then I can close the box up, and it is ready to be put away, as well as the rest of the equipment. Now that we've looked at the Pasco software and you're a little more familiar with it, you need to come Monday ready to be using it. The data that we collected in this video will be uploaded for you guys. That way you can download and play around with the software, familiarize yourself with it, as well as how to do regressions, how to highlight data, move selections. That way you're ready to go first thing Monday.